Doing Hangout.
Yeah.
So using the software to broadcast to YouTube.
Right, exactly. So you're a participant,
Yeah.
and you're sharing your screen.
Yeah.
Okay. What do they see? Okay, it's supposed to be working, but
You're going to log in and see what I see.
yeah, I mean, yeah, sure.
Where should I go? I'm in a Slack channel, so if there's,
Go to the go to YouTube. Hold on, let me see. Oh, okay, I know what's going on. Okay.
what was it?
Hold on. Okay, it's live, but see the Swift logo. Oh my gosh. I think now it should work. Oh, that's you. Oh, you're in. Yeah.
That's fine.
Okay. Yeah.
So,
All right. Wait. Can everyone hear or?
okay, so I'm unmuting my microphone.
Okay. You should probably unmute it.
Yeah, the one's unmuted. Oh, stop. Just going to share. Okay. So 1, 2, 3, 1, 2, 3. Doing good. Okay, so you probably need to. Here it is. Fantastic. Yep. And if you maybe just please. Oh no, actually no, you don't need to. That's fine. That's great. Okay. So
Welcome everyone. This is a vet for Swift, and today we're going to be getting into server-side Swift. Then you have a speaker from Perfect on server-side development for Swift, and as one of the first pioneers of server-side Swift, we hope to change the way server-side is done in the industry. And here I give you Jonathon Guthrie, who is going to give you a talk today.
Great. Thank you, Mohammed. So it's great to be here down in New York City. It's actually a lot warmer than back in Toronto, where I live. So first things first, I'm from New Zealand, so my accent might be a little different than what you may be used to, but that's completely okay because well, we're all different, and if you can't understand me, then just maybe sing out on the YouTube channel in terms of Slack YouTube channel in terms of chat to ask for clarification, and Mohammed will pick that up. Any of you sitting out there in the seats, sing out if you put your hand up or whatever you need me to repeat. Okay, so as I said, my name is Jonathon Guthrie. I work for Perfectly Soft up in Toronto. The vision of the company is that when Swift was released, we immediately saw that this was it had potential to be an amazing general purpose programming language. By general purpose, I mean not just for iOS or macOS. So especially when Apple announced plans to open source Swift, we saw the potential to take this to server side, because it's not just about the ability for someone to run something on their macOS or iOS device, but to have a really good environment for server-side development. And there are some fantastic languages out there. I've used a bunch of them over my career. Each has Node.js. It's obvious the reason why Node.js is popular. It's because of the fact that you can use JavaScript on the front end for web applications as well as on the back end. So then you get the Rails. Rails is easy because of the fact that it does it all for you. And Python, look, there's a reason for every single one of these languages that exists on the server as well as in various different scripting environments. But we saw the potential of Swift. So when the opportunity came up, we jumped at it. And we were the first to release our products. In fact, actually, I think before Apple even physically open sourced Swift, I think we were just a little bit before that. we put our framework out. Now, a lot of that was actually a bit of guesswork because it was actually based on some things that we didn't really know how it actually worked under the hood because Apple hadn't released that code. However, then we set about re-engineering Perfect so that it took advantage of some things that we saw possible, and that's where Perfect 2 comes in. Is that Perfect 2 is a brand new thing that leverages Swift 3, and in fact actually pushes Swift 3 and extends Swift 3. What I'd like to do is actually just give a very quick introduction to server-side development and server-side Swift. Then we'll move on to some live code. So very quickly, first of all, what happens server-side? Pretty much everyone's familiar with the concept of the fact that you get a web page. It submits stuff to and gets stuff to and from the this big black box of the server. The same deal happens when you've actually got when you've got your mobile device that's communicating. The app is actually communicating with the server at the back end. It's to and fro communication. It just so happens that effectively it's the same data, just delivered in a slightly different format. But once you get beyond that simple part, you're actually looking at if there's no framework, if there's no frame of reference, then you have to write everything. You have to write the router, the HTTP parser, the network code, the web server, the handlers, the database connectors. If you really get stuck into it, then you have to write the ORM, the authentication. Well, you end up by writing the entire stack, and that makes no sense for something that's a relatively small application. It might make sense if you're actually building a massive thing that's going to exist for decades. And the reality is that's where some of our legacy code actually is now. But the practicalities for the average developer is the fact that you need a framework, you need a frame of reference, you need a toolkit, and that's where we come in. So what Perfect has done is actually said, well, what goes into making up the framework, the toolkit, the router, the parser, the network code, the web server, the database connectors, the ORM, the authentication. That means that we write that stuff and you guys can leverage it. You're writing the routes and the handlers. You're writing, as you can see on the slide, you're writing the code that matters. Okay. You don't have to continue to repeat these common tasks that are always actually going to be, almost always going to be used in various different ways in a framework. Okay. So I mentioned before about the fact that there are these other languages out there, and why Swift? Why did we decide that we wanted to go down the Swift route? Well, first of all, performance. It's oh. Okay, so first of all, let's just have a look at the raw horsepower equation. Okay, everyone knows Ruby's slow. Okay, everyone knows that Rails is slow. That's because of the fact that in many ways it's a language that's not necessarily being used for its strength all the time. But that's okay. Now let's have a look at JavaScript. I mean, honestly, what was JavaScript written for? It was actually written to solve the client-side equation, and then it got co-opted to be to also be used on the server. Okay, so it's a hell of a lot better than Ruby, a hell of a lot better than Rails, but it's not overly fast. And some Node.js apologists are going to take me to task about that because everyone's got their excuses. But the reality is, these are third-party raw horsepower performance indicators. You have a look at Java. I mean, Java's great, and it's fast, but it's also, as I was speaking to Mohammed tonight, it's verbose, and it's actually starting to show you its age as well. Okay, but then, I mean, we've got Swift. Now, Swift was actually engineered from the ground up to actually be a modern language, to actually be taking advantage of some of the things that the language researchers have come up in terms of, you know, great things over the years. You know, then let's have a look at performance. You know, framework performance. The throughput is huge. I mean, so this is a third party. Once again, Ryan Collins. The okay, you know, full disclosure, perfect. Did actually pay him a little bit of money to actually help him to keep getting fed while he actually did some of his research. But we made it absolutely clear, and he was on board about this, is the fact that he wanted to remain completely impartial. And he did a fantastic series of studies. That reality is we don't come out perfect on, you know, perfect on top every single time, but that's okay. This is an example of where everyone's really close, but everyone's still ahead of Node.js. Swift versus Common Solutions. This is another, I mean, this is tech and power. These guys are also very impartial, very third party. We didn't even do, or even ask them. They just appeared one day, and we validated them, and they're actually quite correct. Longer is better. Memory. I'll get to the reason why memory matters soon, but you know, once again, we took the same four and we compared the same statistics. Now this is, you know, let's be clear here. This is Swift. This is not perfect. This is Swift. This also, I think, was actually Swift 2.2, which is actually not as fast as Swift 3. So you've got Ruby that is pretty high memory usage. Node.js a little better. Java a little more. But Swift for the same tasks, the spectral norm analysis, which is an industry standard, relatively demanding benchmark. You know, Swift comes out ahead once again. Starting memory. So once again, this is taken from Ryan Collins' studies. Node.js, so having exactly the same application effectively that has actually been built in Node.js, fired up, measured in terms of starting memory, and then the same application in Perfect, in Swift, and it consumes a lot less memory. Now let's have a look and see what actually happens when the load is actually increased. Could you get a volume turns low for every 10th word or so? Okay, so I'm just going to break for a moment and just try and increase my microphone volume. Sound. Here it is. Okay. So let's try that. So that should have increased the volume. Okay, so memory unload. Once again, let's recap. This is Ryan Collins. Once you actually subject an application to some real load, then you get to start to see what it's going to perform like and what it's going to consume, what resources it's going to consume. Nobody likes to actually see something from 15 to 245. I'd much rather actually see going from 1.3 to 2.6 under the same load. And the reality is that actually has some significant impact upon memory resource usage. So it's an economics issue. It really is an economics issue. Deflection points. So what I've circled here is, these are example graphs. They're meant to try and illustrate my point. Okay. So once you get to the point where your rate of change starts to significantly increase, there are studies that, well, not studies, but there are algorithms that actually exactly what you actually do. But as soon as your rate of change starts to actually increase, at that point, you need to scale horizontally. Okay, so by scaling horizontally, I mean in an array of nodes that is, say, an AWS node, load balancer. Once the memory or the performance or throughput, latency, etc., starts to you need to add more nodes so that the load is actually distributed more. Now, that costs. And the reality is that, so the reality is that if you get a node that costs $20 a month, okay, and you've got 5 of those, then that's actually going to cost you $100 a month. If you've got, for the same application on a resource-intensive platform, you have, say for instance, it's costing you $50 a month instead of 20, or even $100 a month instead of 20. So that 50 becomes, you're spending 250 to start with, or 500 to start with. You then add one more node. If it's $20, you're spending 120. If you're spending $50 per node, you're spending 300. If you're spending $100 a month, 600, not 500. You see what I mean in terms of the scales of economics. Okay, if you can, in other words, if you can have a node that does more for less, you need to scale horizontally. It's a lot more economically feasible. Okay, the next thing is what it actually really means is that you can take a monolithic architecture and you can break it down into microservices. What that also means is that, well, as these emojis actually show, instead of cleaning up one big pile of, the brown stuff, you can actually scoop up and replace and clean up one small pile at a time. Okay, whereas if it's a monolithic architecture, then if something goes wrong, everything's wrong. Okay, so that's a topic for another day. Next thing, fragmented development. So we're talking here about iOS, Java, and then other random stuff, and in terms of the client side for mobile devices. You've then got a huge pile of potential options. Now the difficulty here is the fact that you've got different front-end teams to your back-end team, and they are often working in different languages. They're often working in different IDEs, different environments, and they don't talk to each other very well. They can't read each other's code, and so it leads to a massive mess. What we really want to see is something a little bit more like this, so isomorphic development. Now, ironically, the isomorphic development wasn't actually coined by us. It was actually by one of our competitors, but that's okay because they're right. What it's actually about is using the same language for your front end and back end development. It's huge. It means that, you're then in a situation where your front and your back end teams are actually speaking the same language to each other. They can both actually read each other's code. They can potentially suggest changes or updates. They can send each other pull requests. It means that you're bringing the front and the back end teams closer together, and that is one of the biggest reasons why we see that that Swift on the server and Swift on the client side is huge. Now you notice there that I've actually still got Java. The rest have become pretty much irrelevant. It's now basically, it's a two-horse race between Android and iOS. I believe that in the not too far distant future, you're actually going to see Swift on Android. Okay, yeah, exactly. So, look, the reality is you can already run Swift on Android. Business logic, you just can't use it for user interface. Now, one day someone's actually going to change that. That's not our focus. we're going to leave that one to someone else to change the world with. Okay.
Swift isn't natively run on Android, is it? It's kind of like down compiling into.
Yeah, I think there may be some transpiling going on. I'm not 100% certain. I haven't really jumped into that too much. I don't have, well, actually, I do have an Android device. It's a tablet, and really the only reason why I keep that around is because I have a game that I can't transfer the account onto the iOS device, and I keep hassling developers about it. But that's another story too. All right, okay, so getting started. One of the things that we are also really struggling to make happen, but actually, really, this is one of our goals, is to actually help people get onboarded. It's the on-ramp to using Swift on the server side. So there's a couple of things. Well, actually, there's several things. First of all, we have a Slack channel. We've just rolled over 1,000 users in 3 months on Slack. And if you go to perfect.ly, then you can join our Slack channel. You can either then use it on the web or via the dedicated client on the desktop or on your mobile device. We're there a lot. And if we're not there, then somebody else is there, okay? We obviously have general, we have help. We even actually have a learning Swift channel, and that is a channel where we specifically state there is no dumb question, only one asked, okay? So please come and join us on Slack. We welcome everyone. The next one is something that we've actually just released. It's currently in beta, but won't be in beta for very long because it's been so successful and there's actually been so few bugs. It's the Perfect Assistant. So the Perfect Assistant macOS app, and you run it and you use it to help create your macOS version of the project. It then also includes Docker in the background to help you cross-check against the Linux builds, so that if there's something different on the Linux build that's going to be a gotcha, but it's going to let you know through Xcode because it's integrated with Xcode. Okay, so I encourage you guys to all go and grab that and use that as the basis of using server-side Swift. It's not bound to perfect, even though it's targeted towards perfect. You can use it for you can use it for ZIO if you want, and ZIO project will find it too. Okay, I'll actually be showing that to you in a moment as we get going. And then there's documentation. So there's a huge amount of documentation on the site. There's also, and it's not showing it, this is a slightly older screenshot. There's also the full API documentation. So every single class, extension, enum, struct, function, variable that is public, all documented. Okay. Now, I'll also note every single little bit of the Swift code for the Perfect project is open source, so you can go and view that as well. There's the link to the GitHub repos in the top right-hand corner of that as well. Okay. There's also example. We occasionally go through example blitzes of an example a day, and I think I did 7 yesterday. But there's lots there, and if you have a specific example that you want, reach out to me on Slack and just ask us, and we'll make it happen. Okay, so let's get going, and let's do some code. First of all, to those on YouTube, how's the volume now? Is that better? No comments? No?
It's a little delayed, so you'll get comments. So you'll get
Okay, we'll hear some. That's fine. Okay.
Anything wrong with the video or audio, if you like us to fix and stuff, feel free to ask.
Yeah. Okay, so this is the Perfect Assistant. So the Perfect Assistant, as I said, is a Mac OS app, and
Could be better.
it could be better.
Yeah, so I guess I'll put the volume up.
Okay, I'll put the volume up a little more. All the way up.
All the way.
All the way.
All the way.
Okay, let's just hope it doesn't peak too much. Yeah. Yeah, there's probably a compressor happening there. Yeah. All right, okay, so. Oh, that might be the peak.
Oh,
Or maybe because I was a little loud. So let's leave it there and let's see what happens. Okay, fantastic. Yeah, it might move it there.
Yeah, okay, because it might just round down.
Yeah. Oh, it's a good little experiment anyway. Okay, so so yeah, back to the Perfect Assistant. So on the left, you'll see that there's actually a whole list of projects, and so these are all the projects that I currently have loaded. Periodically, I clean them out because I have so many. And then down the bottom is the deployments. So the Perfect Assistant is great for not just simply creating projects and helping you manage dependencies. It's actually good for deployment as well. So we have currently deployment options for AWS. There's going to be a lot more coming. We're planning Azure and a whole bunch of others. Okay, so if you're wanting to deploy to your favorite Linux host, then more people that keep asking us for a specific one, the more likely we are to add it. So talk to us. Okay, and it's a one-click deploy. That's the now. Create new project. So tonight we're going to create a JSON API, which is a relatively simple backend that might be used for login and authentication for games and creating some preferences. Okay, so create a new project. It gives you the ability to start a new project with a simple template or an empty executable project. Which might be good for, say, a server-side or a client or a desktop script. An empty library project, which might be really good for a Swift package manager module, or to actually clone a custom repository URL. But tonight we're actually going to make use of one of the examples that are loaded by default, and that is the Perfect Turnstile with SQLite project. Okay. So this example, Turnstile is an authentication system that comes from Stormpath, which is a company that authentication is a service company in San Francisco, and Edward Yang kindly created an open source to his Turnstile authentication system. Then we did some integration with Perfect. Actually, integration more tightly integrated it. Okay, so tonight we're going to use this as our foundation because it gives us the ability to have what's built in. Okay, so next, and I'm going to choose where to save it. Tests and try Swift NYC. Okay, so it's my project directory. Project name is Swift NYC. Save. And you can see on the bottom that it's in terms of the terminal stuff. A command line script is actually running to go and get everything, all the dependencies. So everything is pre-prepared for us. Everything's actually taken care of. And at the moment, in a few minutes, in a few seconds, really, we're actually going to get an Xcode project generated for us. Okay, so you'll see there that it's generated by Swift NYC.Xcode proj. And for those iOS developers out there, that will be music to your ears because you're able to use the same for your iOS and macOS projects. Okay, so project TrySwift NYC has the following dependencies: Turnstile SQLite, and request logger. Now you might say, well, hang on a minute, but I saw a whole pile of others. Well, the reality is that these dependencies have dependencies themselves. So what's actually happened is Swift Package Manager, which ships with Swift 3, manages this for you. So it means that it's gone out and resolved everything, fetched everything, checked everything out, and prepared it all for you. Okay, so open project directory. You'll see that we have a package.swift, and that's actually the file that is giving us our initial dependencies. Now, is that big enough? I can probably make that bigger, actually. Presentation. Here we go. Okay, so what this is actually showing us is that it's the configuration file for the for the project. We have the package description, name, try Swift NYC, and we've got a couple of dependencies in there as well. The perfect style SQLite is the project which gives us our authentication layer with SQLite drivers and ORMs. Okay, the request logger is really just to actually, it's the standard HTTP request logger that shows us what's happening. Okay, so from that, we've actually got all of our packages. So these are all the dependencies that have been automatically checked out for us. So if you use Node.js, then this is similar to NPM. Okay, if you use Ruby, this is similar to Gems. But here we have our sources, which currently just has a main.swift, and we have our Xcode project. So let's open that, and you'll see that we have sources. We have right at the bottom of the sources our main.swift, and all of the dependencies are actually placed above that. That's actually a small bug that I understand is actually going to be fixed. What's actually supposed to happen is they're all supposed to, all the dependencies are supposed to be under a dependencies directory. But apparently that's still to be fixed. But that's okay. So what I'm going to do for now is just select those and new route from selection. Okay. So the first thing I'm going to do is do a build, because you'll see that it's giving me an error here, saying it can't. It's going to say that no such module perfect lib. And that's because there's been no build actually done, so therefore Xcode has no knowledge of the dependencies directly as it hasn't cached them. Okay, so it's finished compiling the all the dependencies and the main project. So very, very quick tour of what this is in terms of the main file. The main file is importing a bunch of dependencies. So we've got our perfect main library, the web server, the web stuff. Then we've got our ORM, we've got our SQLite ORM driver, we've got our SQLite version of the perfect install system. We've got our request logger, and we've got our turnstile perfect, which is the base layer. Okay. I'm going to rip through a bunch of these things very, very quickly. Down here we're setting things up. Okay, so first of all we need to tell the system that it's going to be using a turnstile perfect realm. A realm is a discrete chunk of settings and processes for the authentication layer. Okay, so that comes from turnstile, then we're defining the SQLite connector, just the database. Where is the database? Where is the database? So we're saying that we actually want to use a SQLite database called AuthDB. We're also setting up whereabouts we actually want the log file to go. Okay. A few extra things we're adding the auth account, and we're doing a setup. We're adding in the tokens and doing the setup for that. So the auth account is the users. For the users. Okay, the token, when someone logs in, they need to actually be given a token. So it's effectively your cookie. Okay, your cookie or your authentication token that you're actually sending back in a JSON API context. Okay. For now, I've commented out the Facebook and the Google login. We're setting up our HTTP server, line 53. We're adding some routes, and I'll explain the routes to you in a few minutes. But these are our authentication routes, and they come standard. We don't have to do anything with them. They're just there for us by default. And then we're actually physically adding them to the server. Now I'm actually going to make a change to make this slightly simpler. We can actually define those directly in there. So that actually just cuts down a couple of lines of code. So we're also then going to add some custom routes. Okay, so here is an API v1 test. So we just want to be able to actually what happens, and we're accepting a GET request from /API v1 test, and we're directing the processing that to a handler. Okay, that's another way of doing things. And a third way of doing things is to actually have a route that is just simply embedded in there, and we're not handing it off to another function. It's it's just in the block here. Okay, and I'll show that to you in a moment too. We've actually then got another one where authentication will not be enforced. I will explain the reason for those demonstration methods in a moment too. Okay. Request loggers, that's really just setting up the ability for the HTTP logging to actually happen. You'll see that in action in just a few minutes. The authentication configuration. We want to be able to include or exclude various different routes from authentication based upon various different rules. These set up the rules. All of this documentation is actually available on the website. So I'm going to publish this finished demo at the end. You can pick through it and if you want to have a look at the API documentation or the more textual documentation later. We have so Perfect doesn't have the concept of middleware. It actually has the concept of filters. So it's a different way of looking at how to process changes or checks, etc. So a request filter happens before the handler gets to it. So if you imagine that the request comes in from the API or from the browser, it gets intercepted by the request filters first. They work out whether or not there are things that need to be done or not done, and then it gets passed through to the handler. It then processes the request as per what it was told that it can do or can't do from the filters, and then it passes out the other side after supposedly complete from the handler, comes back out the response filter. So the response filters do things like they set the cookie. Okay, so they physically set the parameters for the cookie at the end. And then we're defining what port is going to be on and where we're going to find our static files. And then eventually we're actually going to start the server. Now it seems that we've actually gone and done a whole huge complex bunch of things, but yep. Yes, so the filters are primarily for things like security. Okay, so now that question's actually been asked. So the question for better audio, just in case you didn't hear that, was do the filters make it more secure? Okay, so actually what the filters do is, because they intercept the incoming request before the handler is executed, means that if the conditions need to be done, if the conditions need to be that the request has got to be authenticated to be executed, then the filter is the thing that can say yes or no. It should even get to the handler. Okay, so the filters are actually critical to things like authentication. Now, one of the other things that filters can do is they can actually intercept and check for things like CSRF attacks, so cross-site request forgery. They can also filter for things like an HTTP request for something that doesn't have a referral header, but does have so therefore that could actually be a malicious attack as well. So actually it's for doing things like authentication, for security, for checking, to make absolutely sure that your application is bulletproof. That filters that's brilliant for a brilliant use for it. Okay, so once again, look for some cool new things that Perfect is coming out with in the next few weeks to do with things like CSRF and other security-related things, because it's actually one of our current focus. So, brilliant question. Okay, so now that I've explained it, let's give you some context. Okay, so I just hit the run button and nothing's happened because I didn't really look at what I was doing. Whenever you create a new Xcode project, it helpfully gives you, okay, you'll see that it's given me one with a suitcase or toolkit thing. It's a golden icon. Now that's actually a library. Now the thing is that we actually wanted the executable, which is the black icon. Okay, so I'm going to select that. I also then actually want to edit the scheme to use my custom working directory. So that actually happens to be my project directory. I'll explain the reason why in a moment. I'm going to run it again. Does a quick build. And down the bottom is effectively my my console view. Okay. In Chrome, so localhost 8181. That's that was the port and the address that I actually got it fired up on, that I got it fired up on in my in Xcode. Okay. So I just hit the root, and you'll see that the request logger is the thing that's actually said that 2 milliseconds, 1,225 bytes from that IP address or that route. And then it's also logging the fact that it's actually statically served styles and a favicon. Now, the reason why I set the current project working directory was because of the fact that I wanted to give it access to my web root. Okay, now you see there that it actually had the styles. That's because of the fact that it's looking for web root, which I defined here in my document root, and it's actually looking for inside web root files, it's looking for that CSS file. Okay, and so that's the reason why I've actually told Xcode to use my project directory as the current working directory. Okay. Now, what that's also done is it's given me access to be able to use some template files. You saw here in the browser, it showed me a login with some HTML. Now that's actually driven from a Mustache template. So we're here today for JSON API stuff for mobile stuff, but this is actually quite important for anything that you're actually going to do for an administration panel. Okay, if you want to do a web admin panel, I strongly encourage you to actually check out the Mustache stuff. It's a great way of doing some very, very easy, simple logic templates. Okay, we're not going to get caught up in that today. What I then want to show you, however, is this. The fact that under Postman. So Postman is a great tool for being able to access APIs. So a JSON API, you can't really do get and post requests and all these sorts of fancy things from a browser. You can really only do things like get and post. And it's really hard to mock things up to do specific reproducible testing. This is where tools like Postman come in. So you'll see that, that if I go back to my Chrome, I've got a login, I've got register. Now I'm just going to use this I'm going to create an account, okay? So username Jono and my super secure password Jono. And no, I don't want you to. And so what it's actually done is it's completed the registration, and it's brought me back to the same page I was before, but instead of just saying, hi, if you want to log in here, it's actually given me my ID. So this is my session ID, 3KOF, etc. If I go and have a look at my cookies, gosh, whereabouts do you get your cookies in Chrome? I normally use Safari. Local storage, cookies. Here we go. Okay. So to install session, you'll see that in actual fact, what's happened is that will be my physical ID. That's actually my user ID, and my session ID is the AFD, etc. So very quickly in terminal, in fact, I'm going to go straight to the project terminal. So SQLite is a great teaching database. If you guys have used something like Postgres or CouchDB or Mongo or MySQL, they're production-ready databases. SQLite is not a production-ready database. It is a great teaching and demonstration tool. Don't use it in production. Take my word from it, because I've used it in production, and I think I say for everyone on that team, we regretted it ever since. But that's okay.
What happened? Did it hack or something? Or?
No, it's we used it to solve a specific problem. Okay, we used it to solve the problem of storing local data to an application. It was actually a server-side application, but the server application has had many thousands and thousands of instances installed on servers around the world. And occasionally what actually happens is that SQLite tables get screwed up or left locked open, etc. And of course, usually it's a fault of hardware or other external software sources or whatever, that things go bad. But of course, what happens is that we get the blame. So it's never necessarily the application server's fault that we wrote. It's often external circumstances, but because it's involved in these application server we wrote, we're the ones that are told to, you know, sort it out. And that it's difficult when you don't necessarily know why something's actually going to blow up. So we learned the lesson the hard way. Don't use SQLite in production. The same mistakes we did. Anyway, I digress. So here we are. We've actually got SQLite 3, and what do we call it? We call it AuthDB. Okay, so I can actually see that the system has actually created a users table and a tokens table. Okay, is that big enough for everyone to see? Okay, so there's two tables there. And if I select star from users, you'll see that there is a user ID. There's the first column. That's my name, and then an encrypted password. And those are the three columns that are populated. Okay. If I select start from tokens, you'll see that once again we've actually got a session ID, we've got a user ID, and we've got a couple of things. We've got a created integer date and an updated integer date and a idle time expiry. And if anyone wants to get into session theory later on with me, you know, let's talk. I've just written the session drivers, so some dedicated session drivers, and I'd like, you know, happy to share and show you code. Okay, so equip. So that's just to prove the fact we've actually got user account here and we've actually got a token. Okay, so that was our token. I'm just going to copy that, and I'm going to go back to Postman. Now, Postman, I have a couple some routes that that I created when I was actually testing these things. Okay, so first of all, we've got a JSON API route that is API v1 login. Now, this one obviously has no authentication, no authorization authentication, but we're sending form data, username Jono, password Jono. It's exactly what we did in terms of our web stuff, right? Now, this is where we've got to be very, very wary of the similarities and the differences of JSON APIs versus the web. This is where they're basically the same. Okay, so if I was to actually press send, then it's actually going to log me in. Okay, register is exactly the same sort of deal. Okay, but this one's a post request to API v1 register with donkey and Kong, and I'm going to send that, and I'm going to get back the login. Okay, error none. Okay, so interesting enough, that's actually, it has registered, but it hasn't actually reflected back the user account ID. It probably should, and that's probably an improvement that I'll make later on. Now, I'm going to show you that test route. Okay, so this one here, this test route, is using the authorization bearer token methodology. So it means that we have got an authorization header with a bearer space and then the token. So it's a standardized methodology for authentication. We send that, and it's actually going to say authenticated is false. Okay, if I go and change that token to the one that I copied out just now and send that, it's actually going to say auth true. Okay, and then a bunch of other things that actually gives you that we'll use a little bit later on. So we can then have a look back here and actually say, well, there were some other routes in there as well. There was the check and the no check. So these are to show you how you actually can filter things for enforcing authentication, or saying, hey, look, I don't want you to have it. So check. We go back to Postman, and under the authorization bearer token header, we've got a completely invalid token. I'm going to press send, and it's given me a 401 unauthorized. So instead of processing it and doing whatever it's going to do, it's actually stopped it from even getting the handle. And that's the whole point, right? But there's no check. Okay, it doesn't matter if I give it a authorization bearer token or not. It's just going to do it. Okay, so that's why that's how you can actually say yes, authorize or not. I'm going to give you content that might be customized to your authorization, or no, you're not even going to get there. So that's the whole purpose of multiple filters, as I described before. Okay. So now that I've given you the understanding of how the system is currently configured to actually work, let's actually create some stuff. So, as I said right at the start, when you get a mobile app, you want to create a backend for it. Generally, what you actually want to do is you want to allow people to register, to log in, but then to do things like save preferences or to send scores of the game, and to do things like retrieving high scores, to do things like retrieving news, to do things like receiving things from the server that are, say, rewards for progress in the game, and all these sorts of things. Some of them you want to be authenticated and some of them you don't want to be authenticated. But the main thing that is actually used by almost every single backend is a preference storage system. Okay, so that's the number one thing that people say, well, how do we set up preferences? So we're going to go and create a simple handler, a simple data structure, a simple backend storage, and then we're going to be able to save them and retrieve them. Okay, so that's the goal of what I want to be able to do tonight. First of all, I need to have some coke. All right. So how do we add a route? Well, we could just add a route in the body of the request, like this, and then have the handler, the body of the main.swift, and then have the handler embedded. Well, that's pretty lame. The reality is what we want to try and do is we want to split things out into files that make sense. First of all, let's design our object. Okay, so let's create a new file, and it's because Xcode hasn't really caught up with modern day Swift programming and server-side stuff. We're just going to use macOS and then Swift. So next. And I'm going to call this prefs.swift. And the target that I want it to go to is going to be try Swift NYC. Okay, so first of all, we can get rid of the foundation, but in actual fact, what we want to try and do is we want to say, well, what are the things we wanted to use? Well, first of all, we want it to be able to be backed by a SQLite ORM. So we need to do two things there. We need to import the base ORM, and then we need to import the SQLite driver for the ORM. Okay, so this is going to give us access to all of the goodness that comes with any typical ORM, and that is, so an ORM is an object relational mapping. And that means that we can get a struct or a structure like in a class, and then map that in terms of its properties to a database. Okay, so we've actually already seen this in action with the account. with the user account and with the tokens. But now we're actually going to create it for ourselves. Okay, so I'm going to create a class, and the name will say prefs, and it's going to be, actually, we need to inherit. So we're going to inherit from SQLite Storm. That's going to give us all of our typical methods you'd expect from an ORM, like save, get, find, etc., etc. Now, what do we want in terms of our properties? So generally, we want to actually do two things. First of all, we want to have it associated with a user account. Okay, so our user ID. Okay, and we know that this is actually going to be a string. And I like skipping initializers unless they're needed. In this case, we don't need to. Yeah. Well, hey, look, the reality is that there is a time and a place for initializers, right? So, because if you just, have your var user ID and then declare it as a string, okay, then you have to have it in it that sets everything up. But if you know that in this case, it's going to have default values of nothing, and we're actually not needing to really set things up, well, why have an initializer? So, I'm in favor of skipping the initializers and just declaring default values if needed, okay? And Swift is great because it's what you're actually, the type casting that you're doing. So that automatically knows that it's a string. It's not having to try and say, oh, what sort of string? No, it's just a string, Okay, so now what is frequently done, the mistake is of many people in many database situations that I've seen over the years, is that they try and explicitly set every single possible option. So, they might say, what sort of preference is it? Oh, it's a name a preference in a game. Oh, guys.
Color.
Color. Okay. Favorite color. Okay. So they'll have a column or a property for favorite color. Okay. Then they'll have what size shoe do you wear? And then they'll store that as a separate column. Well, the reality is that that as soon as you then have something else you want to add or store, you've got to add another column for that. So you've got to go back and retrospectively add another property to your class. You have to make sure that's actually managed. You then have to go and make sure that that's actually backed by some changes in the database, et cetera, et cetera, et cetera. Well, quite frankly, that's stupid. This is where NoSQL comes in, but we can, in this case, we can hack a SQLite database or a SQL database to actually store JSON, and that's actually then going to get written as JSON and then read back out as JSON back into our object. But the easiest way to actually store this, however, is something that we can access internally, is by having a var and we'll call this data equals, and we're going to make this a string any. And we're going to initialize it, right? So we have our unstructured storage already set up for us. Okay, now there's a couple of things that we actually need to add in that the ORM can't necessarily determine all by itself, okay? So, well, first of all, we need to actually create a function that is, I'm going to grab a snippet here. So, yeah, guys, you'll notice that I've done this before, okay? All right, no problem. So I'm adding in here a function that defines table. Okay, now what we could do is we could actually say that it should maybe echo the lowercase equivalent of my class name. But there are so many things where that is actually going different. Okay, you might want a namespace for tables, as an example. You might want to call this user preferences, but your class, let's just call it prefs. Okay, so that's why in this case I'm saying, hey, let's actually override it and just show you that that's actually how it's done. Okay. The next thing is that so there's a couple of things that I'm just going to grab here, a couple of functions, and I'll explain why in a moment. Okay. So first of all, I called this data, not prefs, so I'm just going to change that, and everything else is good. Now, so I'm not talking to right now to the guys and girls that are on YouTube. How many of you guys are comp sci students? Computer science? Okay. Okay. So, do you understand what I mean when I talk about introspection? Okay, so introspection, a little bit like the like navel gazing. Okay, it's like inward looking. It's you're thinking about yourself, looking at yourself, and analyzing. Okay, so it's that sort of stuff, right? That's the concept. That's what introspection means in terms of the English language concept word. The same thing is applied to introspection of a language. So many languages have introspection features where the language itself can go and look at what a class is, what its properties are, in some cases be able to actually determine the type of the properties and determine what functions it has and that sorts of things. Now, Objective-C, if you've used Objective-C, the introspection in Objective-C is first class. It's amazing. It's great. The introspection in Swift is suboptimal. It is one of the weaker aspects of Swift, even Swift 3. I do know that they've actually been talking about strengthening it and making it better, but that's not going to probably come until probably October of 2017 when we get Swift 4. And it's a little frustrating for those of us that actually need to use introspection, like those of us that write ORMs, because introspection is really important to be able to look at a class and say, I have a user ID and a data property. Now, Swift 3 can see that we've got a user ID and a data property, can actually also see that it's a string and it's a dictionary. And it can also see the values, but it can't write back to them. So these two functions, unfortunately, are actually all about trying to write back to the data within the class, within the instance of the class. Okay, so that's a really long explanation for something that I shouldn't need to go on about. The sort of team, I think, knows how the community feels about fiction. So if any of you guys are listening at any point, then I'm not going to harp on. Anyway, so that's one of the reasons why I've actually gone copied and pasted. The principle of what we're actually doing here is that when we're throwing data back into the class, we're setting the user ID property as the data member, user ID, optional as string. If it doesn't have if there's no value, then it's going to supply an empty string. Okay, and then what we're doing here is we're just simply saying, if there's substance to the data property, then this is how we're going to address it. And in this case, we're going to address it by setting the data property to some from the JSON string. We're going to interpret into a dictionary. Does that make sense? Okay, and then we just simply, if it came up with an error, then it's just going to print it to the console. And do nothing further, because in theory the dictionary property will actually be empty.
Why is the let O to OBJS string. Why is that needed?
Okay. The reason for that is, I mean, in theory, you could actually put that up into here, but I found some edge cases where it wasn't falling through correctly, or it was falling through incorrectly. So I took the opportunity to just simply have a two-step process. Okay, and I've actually since learned some other techniques which actually might help me to minimize that code a little bit. But that was a slightly longer-winded but more safe way. Because the reality is you want to try and minimize the places where your code has an exception or can generate an exception on the server side, because all of a sudden it's going to go bang. And unless you have a script to actually restart it, because it's not like an iOS app on your phone where it crashes on me, I just reopen it. It's a little more difficult on the server. As soon as something goes bang, then hopefully something on the server is actually going to push the application back up again. But we want to try and minimize the number of situations where that may happen, because you want the server to keep running, right? Okay, so let's move on. We actually have a fully functional preferences class. Okay, we want to know what to do with it, however. The cool thing is that, as I said before, because we've inherited the SQLite storm, we've actually got all of the functionality. We don't have to write a save method, we don't have to write a get method, don't have to write a find method, all these sorts of things we just simply don't have to worry about. However, what we have to do is, in order to get that to be set up, we have to go back to main.swift, scroll to the top, and you'll see how we actually have our let auth equals auth account and then the setup. We're going to do the same thing for our preferences table. Okay. So I've just gone on the copy paste. So preferences table, let pref equal prefs, and then pref setup. Okay. That's all we need to do to actually make sure that when the application starts, it's going to make sure that there is a preference table that exists. Okay, so I'm going to run that, and you'll see there that it's running setup prefs. If we go back to our command line and schema, absolutely. Here we go. So you'll see now that we actually have a third table. So that's our users table, tokens table, and it's created our preferences table. Okay, just got two columns: user ID and our data column. Okay. So next thing we have to do is we have to actually create a handler to save some prefs. Now, generally, what's actually going to happen is that you're going to get the ability to how do you send data in a post request? It's either as name value pairs, which is restrictive because it's a name value pair, okay? And you can have a whole lot of them, but they're still name value pairs. If you want to have structured data, which is really what JSON is, then you want to actually pass that in as JSON, okay? Which gives you the ability to actually have an object, a structured object of information that belongs to another object, and so on and so on. And so JSON is actually the much better way of passing data in and out. So if I was to actually come back to Postman and have a look at a post request example body. So I've got here, what I like is soccer. I'm going to add another one and say stuff. And then I'm also going to add another one, another nested object, and that is actually going to be hello or pets. There we go. type tonight. Cat. Okay. So I have a pet cat. And then I'm actually going to say kids. And I'm going to say 2. Okay. So I've got some structured data. But I want to be able to save that via a post request to API v1 prefs. So the first thing we need to do is we need to come back to our Xcode, and I've got here a API v1 test that is going to auth handlers JSON test handler. Well, let's just copy and paste and reuse that. And routes add, it's going to be post. API v1, what I wanted was prefs, wasn't it? Prefs, and we're just going to hand this off to save prefs, or prefs save. Now this prefs save is going to just simply take our request and our response object. And the great thing is that we don't have to specify that in our handler definition. It's just automatically done for us. Okay. So I'm going to create a new file, and I'm going to call this one handlers. Okay. So a couple of things that we actually going to need to actually do is, once again, think about our libraries that we're going to need to import, that we're going to need to have. Now, I have foreknowledge of the fact that I'm going to need the HTTP libraries. Okay, so import HTTP. Here it is. Well, let's just leave it at that for now. The second thing we're going to need is we're going to need effectively a template. Okay. Now, the cool thing about everything being open source is that you can, well, blatantly plagiarize. Okay, so we encourage you to go and have a look at our code, grab it and reuse it. Go and have a look at our code and learn from it. Once again, I think I was talking to someone at the airport today about how to learn, because he noticed that I was a developer, and he says that he's going to Seneca College next year up in Toronto, and talking about wanting to learn, and where can I learn, how can I learn, etc. And I basically said, look, find an open source project with a target of what the sort of thing you're actually doing, read their code, understand it, ask questions, find a forum that you can discuss this stuff, and developers love talking about their code. Okay, there's very few developers that if you ask them nicely enough, will not want to talk about the code they wrote. Okay, so learn from them. So in that vein, what we want to say is let's go and grab some of this code that I've already written. Okay, that I'm actually suggesting to you guys. You know, go and grab the stuff that myself, Tim, Ryan, Kyle, Rocky, you know, the team members have written. If you don't understand it, ask the question in Slack. Learn from us. Okay, I learn from Kyle all the time. I learn from Rocky and Tim and you know, Kyle all the time. Reading Kyle's code, even though I can't sometimes understand it, because I ask what it does and he tells me. So after that little rant, I'm going to show you whereabouts you can actually get that code. Okay, from these dependencies that I placed into a group, what I've actually got is those auth handlers, JSON and web, that were driving the things that are the login and the register and so forth. Okay, so the reality is that we're going to be able to grab some of the stuff and only slightly change it. Okay, so let's go to this JSON and just scroll down very quickly, and you'll see that we've got a login handler post, and that's where we're receiving our request and our response, and we're getting some values in, but these were the name value pairs. Okay, so if we were to use this one, we'd have to change that a little bit, but that's not a major problem. Okay, and then it's doing a bunch of other stuff, and we can mostly ignore that later on. We've also got a register, which is pretty much doing the same thing. It's just instead of registering, it's actually doing a save. And you'll notice that it's doing a register. And if I was to inspect the register, that would actually show me the save operations. We don't need that either. Okay. And then we've got our logout. And then we've got some commented out Facebook, iWorth, and Google iWorth stuff. And then right at the bottom, we've just got that test handler. Okay. The one that we actually want is this login handler post. Okay. So I'm just going to go and grab this, and then we'll strip it out. Okay. So let's do this. First of all, what do we call it? We call it press save. Okay. So I copied it from a class, and we're just having it as a function. So there we go, press save. It's consuming our request and our response object. We're then forcing this to actually be application JSON as our content type. Okay, if we were just leaving that out, then it would actually try and set it as text HTML, and we don't really want that in this scenario. Our response, we're just going to call this a string for now. Although later on we're going to call it differently. But the reality is that we don't want to have username and password. So let's have a look at what things our request can actually give us. So using the autocomplete for Xcode, we can actually see that it's actually got a bunch of these things. So if we were to actually say, if it's coming in the body of the request, let's start typing body. Oh, here we go, post body string. Isn't that convenient? So this is where, if you don't necessarily know what you want, sometimes you can start typing in a little bit of what you want, and you might get your code completion. Worst case scenario, go and have a look at the API documentation or the documentation itself. Okay. So post body request, post body string. So that's the thing that we need to set that. So we're going to put that into let pref or pref data equals that. Okay. Else this thing it doesn't need it. Okay, so if there's no pref data, then it's actually going to respond with saying it's missing data. Okay, and then response completed. Okay. Now let's get rid of all this crap down here, and let's strip out those two and build data. Okay, so I've literally stripped stripped the rest to just simply give me my template. I need to take this this post body string and convert it back to our object. Okay. Now, so in a previous class, I actually got asked, well, if it's coming in as JSON, why not just simply keep it as JSON or store it as JSON? The problem is that if you're going to do that, then you don't know whether or not it was valid JSON. Okay, so you don't know whether or not it was valid data. So this is actually a way of validating our input. Okay, you really should always validate input, but that's once again that's a completely different topic.
Which part exactly handles the validation?
Right. So what we can do here is we can let this data equals ref data dot once again JSON, and we can see JSON def. Okay, and because of the fact that we can actually then go try, it's going to error if it's had a problem. So that's actually our methodology of validating it. Did it decode? Yes, it's valid JSON. If it didn't, then we can send back an invalid data. Okay, does that make sense? I mean, if you were expecting a string and you didn't know if it's a string or not, then you make sure that the data type is a string, et cetera, et cetera. And you can generally also do that, like as you're iterating through your JSON data that's now an object, you can actually see whether or not something is an integer or a string because it usually is set properly.
And that's in this stage of the operation, right? Like in this block of code.
You could do that there, yes.
Because you have access to this data now.
That's right.
Where it's like fully accessible with a dot notation, for example, right? Or a bracket.
Well, yeah, because it's a dictionary.
Right.
And it's a dictionary of dictionaries. So potentially a dictionary of dictionaries. Because it's a string any. Yeah, that way you could actually go through your preference data and actually validate the individual things if you wish. If we have a look at Postman as an example, you could make sure that there is actually a what I like. You could make sure that there's a number of kids within stuff, things like that. Okay. Now, I deliberately haven't actually mentioned the user ID yet, because we're not passing that actually is in the JSON. What we're actually using there is we're actually using the session linkage. Okay, so this is, we're going to add this route in a moment to our authorization check to make absolutely sure that it's authorized. So it's not going to get through here if there is no valid user ID. So I'm going to change this slightly to right at the top. I'm going to var prefs equals prefs. First thing I'm going to do is I'm going to set my user ID to be equal to our user that we should have, right? Now that comes from request dot user dot auth details dot account dot unique ID. Now I've done this a few times, as you can see. Okay, I happen to actually know that that's the path. Now, once again, having a look at examples and actually digging into the code and actually finding this stuff out. It's the more we document and do examples and so forth, the less you'll have to dig. This wasn't really documented when I first did it, and I had to go and find it. And it was one of those, now I know how to get the unique ID. So it's just one of those things that sometimes it's about making absolutely sure that you can understand the code that you're actually using first. Okay, don't be afraid to experiment. Don't be afraid to ask questions, and take lots of hints from Xcode when it tells you exactly like I'm doing now. Okay, now I just created this let this data variable, and the reality is I don't need that anymore, so I can actually just simply pile that straight into prefs.data. Okay, because it's string any. But now, as Xcode is helpfully telling me, I'm going to actually need to say this is the specific format that I actually want this to be decoded into. once again, because we have this in a do catch, if it's invalid, it's going to, and fails this, and then it's going to actually RESB error equals invalid data. Make sense? There's only one problem, we haven't saved it yet. Okay? So, well, how would you normally think that you should save it? Here we go, press not save. Now, actually that's incorrect, but that's actually one way of doing it. So the way the ORM works is that you can call the generic save method. If there is no primary key, then it will do an insert. If there is a primary key, it will do an update. Problem is, we're actually specifying a primary key, so it's going to try and do an update, but there's no row. Okay, so we're actually going to have to actually do a couple of different things right now. First of all, we're actually going to need to call the we're going to need to find out whether or not there is a row. Okay, so up here we've actually already set our pref's user ID. Okay, so let's actually create another object that does exist. Equals prefs, and then I'm actually going to call a does exist dot get. Well, actually, I'll do a find, and I'm going to show you the signatures that it has. No, it's a find. Okay. It actually has two signatures. It will accept an array of tuples, or of a dictionary. Okay, I'm just going to use the dictionary for now, and I'm going to specify that this is actually going to be, what I call it was user ID, and we're going to specify prefs.userid. So what this is going to do is it's going to look to see whether or not there is a existing row. And if there is an existing row, then it's going to populate that user ID back into it. Okay, so it's a little bit of a trick to actually, does it exist? Now, this is also actually played because it needs to be in a try. Okay, so we need to put this into its own do catch block and give it a try. So it can fail if needed. So after it's done its check, we can access it and catch. Let's just print the error for now. That's just going to go to the console. So down here, we want to actually work out whether or not it's going to be a create or a save. Okay, create or an update. Okay. So if prefs.userid does equal what do I call it? Does exist dot user ID. Then we know that it's actually there, and we can call a save. Else, we're going to try prefs dot create. Okay. So this is a way to actually get around the whole primary key existing, primary key not existing. Do I want to save, or do I want to update? What do I want to do? This is basically just it gets around that problem. So let's run it. Okay, back to Postman. First of all, I actually really need to get the correct token. Goes from there. Okay, and send. So that's given me an error none. So that's what I would expect if everything was golden. So select star from prefs. Guess what? We have success. We've got our user ID, and then we've got our JSON encoded nested object string. Okay, it makes sense to actually then have a get. So we want to actually return that now. So back to our main.swift, and let's make a new route. Okay, so routes.add. Okay, to use the autocomplete. Okay. Here it is. HTTP method, it's going to be a get. Okay. URI is actually going to be the same one. And instead of press save, we're going to say press get. Okay. So this demonstrates the fact that you can have the same route but with a different HTTP verb and get a different result. So it's just being filtered upon the HTTP verb. So let's flip back to our handlers. And you know what? I'm just going to once again copy and paste my own work from there, all the way up. Press get. We still want it to be application JSON. Response, we actually want to be string any. So that's the dictionary format for a JSON. For JSON objects is string any. We don't need to have the does exist. We don't need to have the post body check because there is no post body. We don't need to have the decode or that. However, what we actually want to do is we want to do a get. Okay. Now, the reason why I chose this one and not the one where I'm specifying the ID is the fact that it's going to pick up the fact that it already has the ID. Okay, and just go and get it based upon that. And our RESP is going to be data, and we need to encode it as JSON. Okay, so prefs dot data, and then we're going to JSON encoded string. This is going to take our data object and create a JSON encoded string out of it, just like the description actually of the method says.
When it's stored in the SQLite, isn't it already a string?
Yes, but we brought it into the object and into our prefs object and actually saved it and stored it as an object. So yes, there is a little bit of overhead and a little bit of redundancy there, but could you work your way around that? Yes, absolutely.
So it actually is being stored as an object.
Yes, internally.
Right. Oh, okay. Interesting.
Yeah. So it's being stored internally as an object. It's being stored as JSON, and out the other side as JSON. Now, the reason why for this example I chose it to be this way is that then we can natively use some of those preferences to maybe generate some choices of some data that we may or may not want to actually send back.
Yeah.
So rather than having, oh, does it exist as an object or a JSON right now? I don't know. Well, that's a,
So
it
it's kind
exists
of
as an
the
object.
safety.
It's a safety thing.
Yeah.
So once again, I mean, there are different philosophies, different design philosophies and different ideologies as to what's best or what's not. And the reality is that, well,
This is more like you want to be consistent with the model that you have.
that's exactly right. Yes. So choosing a model and then following it through. Okay. And guess what? That's all we need to actually do for that, because it's just simply getting the preferences for that account ID. Okay. And because of the fact that if there is none, okay, if the user has not sent one already, then the object is going to be just simply empty anyway. So it's once again, it's safety. It's just simply going to send